Today's lesson, we're going to make it short and sweet. I'm going to do this in 15 minutes. I'll be very happy. We'll see how well you guys do from there. Basically, there's going to be one statement I'm going to keep saying over and over and over again. If you don't have this written in your notes at least 3 times, or highlighted, or boxed, there is something wrong with your note-taking skills. This is a huge concept to understand with today's lesson, which is we're talking about segment addition and what that actually means. So we look at our objectives for today. Pretty straightforward again. Use the segment addition postulate to find the lengths of segments. And that's all we're going to be doing today. Now, one thing I'd like to do is I want us to do this, but have it focused from a geometric point of view, and then we'll go to the algebraic point of view. We'll discuss what that means here. So, here we have a segment. How many points are on the segment? Okay, and what are those points? Where's B at? Midpoint. Hold on, be careful how you respond. Think about the statement. Where is B at?
Halfway between the middle and the right.
Between
3/4
Well
from the
done.
left.
It is not in the middle. It is not the midpoint. We're not told that it's the midpoint, so we cannot make assumptions. You guys all understand what happens when you assume. Geometry is the one place where you can never assume. The only thing you can assume that if it's my drawings, they're never drawn to scale. That's the only thing you can assume. Now, all we can state here is that B is somewhere between A and C. That's it. We don't know anything about the lengths of AB. We don't know anything about the length of BC. And we certainly don't have any clue how long AC is. All we know is B is between the 2 endpoints. So if I look at point B, the placement of point B divides my segment into how many parts? 2 parts. Are they equal? No. No. They could be, but we don't know that for sure, so we say no, they're not equal. So it divides it into 2 parts. What are those 2 parts? AB and BC. Okay. Does that make sense? We have part AB. You stay there. So we have part AB, and then we also have part BC. Those are my 2 parts, right? AB and BC. So what happens when I take those 2 parts and I put them together? What do I get? So if I take 2 parts and I add them up, what do I get? I get segment AC. Okay? Guys, think about it. If I take a piece of string and I cut it at some random point, but then I take the 2 ends and put them back together, I get the entire length, don't I? If I'm traveling 190 miles and I first I travel 100 miles and I take a little break and get back on, I travel to 90 miles. It is very much the same thing as traveling 190 total, correct? Okay, here's the big idea. The true big idea. The sum of the parts equals the whole. That's it. That's what this whole lesson's about. The sum of the parts is equal to the whole. If I add up all of my parts, I get the whole thing. It's that simple. That's what you just write down. The sum of the parts is equal to the whole. And I would highlight that. I'd write it really big. I'd put stars next to it. I'd go deep inside my backpack and find the stickers that I'll haul around with me. I would do everything in my power to draw attention to that statement that the sum of the parts is equal to the whole. Cannot stress that enough. That's our big idea. Got it? Sum of parts equals the whole. Now, a lot of you guys coming, especially if you're coming around of Algebra 1, you're ready to just jump right back into Algebra 1, get into an equation, you're like, woohoo, I got X's and Y's, we're good to go. I'm going to ask you to slow that down a little bit. Because the difference between high school geometry and high school algebra is one extra step. In algebra, we say, here's the equation, and go beat your head against the wall as you try to solve it. geometry, we're like, hey, I bet you enjoy beating your head against the wall. So now we're going to step it up, and now you figure out the equation, and then go beat your head against the wall trying to solve it. That's the only difference between Algebra 1 and geometry. We are not going to give you the equation. You would have to understand the properties of geometry to set up the equation. It's that one extra step. Sometimes that's a really easy step. Sometimes you beat your head against the wall all day trying to make up that step. Okay. So let's take a look here. We're going to add up the parts. Okay, what I want you guys to practice, again, we have to practice doing this. I want you guys to practice writing the geometric equation. What that means is we are not going to throw in variables. We're going to keep it in geometric language. So let's do example 1. I want to figure out the length of QS. Well, what are the parts that make up QS?
TS.
No, just QS.
QRS?
Those are 3 points. Those aren't the parts.
Wait,
Oh, what did you get?
QR and RS. So the way we write the geometric equation is going to look like QS is equal to QR plus RS. Okay? And the reason why we call it this geometric equation is because it's an equation based on geometric parts.
So are we gonna be like filling
Yeah, eventually you're going to be told what QR is, you're going to be told what RS is, but this right here, this little guy right here, that is the first step. Okay, writing out that geometric equation, because then from there, it's nothing more than substitution. Alright, so let's look at number 2. Trying to figure out the length of QT. Alright, Caleb, how would I write out the equation for QT?
QT equals QR plus RS plus ST.
QR plus RS, what's the last one?
Plus ST.
All done. Okay, Lindsay, number 3, PR. Okay. Oh, that's it. We're trying to get from P to R. So that's PQ and QR, and then we're done. And finally, number 4. Bill?
Going to be PQ plus QR plus RS.
All right, guys, we got this? Sum of parts equals the whole. It's not difficult, is it? Now, I'm going to take a little break here. So I think it's important we talk about this, just because it's something I've seen in the years of teaching geometry. There's a lot of you guys who see this and your brain starts shutting down. Because you see that the Q, a lot of you guys interpret this as Q is separate from S. And so you see this as, well, we got 2 Qs, I got 2 Rs, I got 2 S's, and I'm not really sure what to do. And that's where the huge mistake is. Remember, math is a foreign language. You have to learn to read the language. When we see QS, 2 capital letters next to each other, what does that actually mean? Casey? No.
2 separate points.
No. Guys, this is one variable. QS is one variable. QS actually represents something. What does it represent? Segment QS. That's it. So when you guys are seeing this is, you actually have 3 variables. You have QS as one variable, QR, and RS. 3 different variables. Again, you have to learn to read that. Segment QS is equal to segment QR plus segment RS. Okay? Really have to train your brain to read this stuff. Because otherwise the geometry gets really confusing. So you have to learn to read the math. Okay? Alright, so let's go from there. I feel like you guys got a pretty good handle on that. let's go to where we have to go and put in the algebra.